Here's a guideline for how to do formal conclusions for a hypothesis test. Generally, you'll be given an alpha or significance level. Then you'll find a p-value from some calculations you do using a sample. And the general rule is that you could say when the p-value is low, you should reject the null hypothesis. So when the p-value is low, reject the HO. Of course, it's never called the HO, it's the null hypothesis. What's going on here is a physical representation that we can kind of understand. Our p-value will be at its lowest, 0, and then it could be any number that's higher than that. What are we seeing with alpha? Well, alpha is some predetermined value that has been picked. A lot of times people use alpha equals 5% or 0.05 as a decimal. So somebody will give you the alpha value, and then what you're going to do is you're going to map your p-value out. Where your p-value falls relative to this alpha determines whether you reject the null or not. If it's low, that's where you're going to get the rejection zone. So over in this area here, any value here, if the p-value were to fall to the left because it's smaller than alpha, would give us the rejection region. So this is where we reject the null hypothesis. And if our p-value ends up anywhere on the right side of that or equal to alpha, technically speaking, this is where we would fail to reject the null or not reject the null. Now, the wording in statistics is kind of strange. You would say, well, Chris, isn't that like saying not rejecting the null? Couldn't we just accept the null? No, 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 no. You never say accept in statistics, which is really counterintuitive, right? It's not like you go and ask somebody, hey, will you marry me? And they say, well, I failed to reject you. And then you celebrate. So this wording is kind of strange. The two things that you can do, you can either reject the null or you cannot reject the null. Fail to reject the null. Now, if we were to write these down in the formal cases, here's what we're looking at. This is where our p-value, once again, just as a reminder, p-value is less than alpha. The other side happens when the p-value is greater than alpha. So I'll write it this way, or even equal to. So if our p-value is greater than or equal to. Let's do a quick example of how this works in the formal case, just to show you what you can anticipate with problems that you might be working. So something locally here that's a little closer to home for those that live in this area. What if we wanted to see and test to see if the mean home price in Austin, Texas is less than $300,000? Now, of course, this is probably not the best way to test it. Really, for those that live in the area or have ever looked at houses recently in this area, we probably would actually test to see if it's more than $300,000. It doesn't matter which way you do this. Let me just give you a feel on how this would go. Your hypotheses would get set up as the following. The null hypothesis, excuse me, let's get a little straighter line. The null hypothesis is going to assert that we are, in fact, equal to 300,000. So it would look something like this. Null is asserting that the mu is $300,000. And then the alternative is whatever we're testing for. So in this case, it's more realistic, we said, to test to see if maybe the mean is greater than 300,000. I personally always suggest writing an interpretation as you're doing these just for your own convenience sake. So this one is saying that the population mean home price in Austin is $300,000. And the second statement is the same thing, except you just change one little phrase in there, and you're not going to say is. Is only applies when it is equal. So population mean home, and the alternative is that the price in Austin is greater than 300,000. Now, how does this work? In practice, what happens is we end up getting a sample, and the sample leads us to a p-value. So let's just suppose that all of this ends up happening. We get a small sample of homes, and suppose ... our sample leads us to a p-value that is equal to 0.02. The question is, would we formally reject or not reject the null hypothesis in this case for a specific level of alpha? So let's say the p-value is 2, and let's use, you're allowed to use anything, but let's use alpha equals 0.05. The common levels of alpha are 0.01, aka 1%, 0.05, which is 5%, and 0.1, which is 10%. Now, I like to think of these as percents, but some people don't. So what I would do if I were you is maybe just as you start working problems, go over here, put your tick mark up for alpha. Alpha here would be the equivalent of 5%. And now interpret your p-value. Well, your p-value is 0.02. Move that little decimal over 2 spots, and that would tell you that we would fall about right here. So our p-value is 2%. If you look at the regions that we just placed up here, up at the top, the green zone, this green zone tells us our p-value fell in an area to reject the null. So in this particular problem, what we would end up doing is formally, we would say we would reject the null hypothesis. And the reason we're going to reject the null is simply because there is more evidence from our sample that the mean is probably greater than 300,000. So the statement is, when you reject the null, what you're effectively doing in your mind is this. If you reject the null, it's like crossing that out and saying, oops, then the alternative must be true. So our sample is indicating here that for whatever reason we had a sample and it was showing that the alternative is likely true. So just to give you a heads up on how to do this, I'll post another one here real quickly about informal conclusions and then do a problem that compares both types simultaneously. Keep a lookout more here on the Math Informant for other helpful tips. Take care. Bye-bye.